One way to acquire an electrostatic charge is to come in close contact with another object that consists of different material. Cotton, for example, has greater attraction for electrons than wool. Therefore, when these materials come in close contact with each other, electrons transfer from wool to cotton. The cotton now has an overall negative charge, and the wool an overall positive charge. Their opposite charges account for the static cling when you attempt to separate them. The easiest way to neutralize a charged object is to connect it to the earth with a good conductor called a ground. If the object is negatively charged, the excess electrons flow into the ground until it is neutral. If it is positively charged, electrons flow from the ground into the object until once again it is neutralized. Close contact between two neutral objects is not the only way to acquire an electrostatic charge. If a neutral object is touched by a charged one, there will be a transfer of charge as electrons flow from the charged object to the neutral one. And how do we detect charge? A metal leaf electroscope can be used to detect relatively small quantities of charge.
It's just a thing that detects if there's electric charge. They can look like this, see the stick has a charge, or they can look like this and they wiggle when there's a charge. Back to the video.
When it's touched by a positively charged rod, electrons move from the electroscope onto the rod, leaving an excess of positive charge. As a result, the metal leaves repel each other, evidence that the electroscope is charged. Have you ever noticed that an electroscope, when approached by a charged rod, seems to anticipate what is about to happen? The leaves diverge even though the rod does not make contact. If the rod is removed, the leaves collapse again. What's going on here? Well, let's apply some of the theory we've learned so far. We can visualize the electrical condition of the rod and the electroscope by showing a representative sample of the charges. Since the electroscope is metal, electrons can move with relative ease within it. If, as a result of their random motion, some electrons come close to each other, the repulsive forces that they exert on each other ensure that they will very quickly move apart again. When a positively charged rod moves towards the knob, the charges interact. The electrons in the electroscope will try to move towards the rod. And as they do so, will flow out of the metal leaves, making the leaves positive. As a result, the leaves repel each other and diverge. When the electrons in the electroscope move towards the rod, they get closer to each other and repel each other more strongly. So, for each electron on the knob, the attractive force of the positively charged rod is balanced, both by the repulsive force of the other electrons near it and the attraction of the positively charged leaves. If we look at the electroscope as a whole, we find that the top is negatively charged and the bottom is positively charged. Since no charge has been transferred, the electroscope as a whole is still neutral. It has, however, experienced induced charge separation.
Let's say we have a neutral metal sphere with equal positive and negative charges. We bring a negatively charged rod close to but not touching the metal sphere. The sphere is thus going to polarize as the negatives attract the positive charges, and then they are trying to repel these negative charges. That is why they move as far away as possible from these negative charges.
If the positively charged rod is removed, the electrons will no longer remain concentrated in the knob, but spread out uniformly throughout the electroscope. As a result, the electroscope no longer has induced separation.